We want to determine if the function is even. We've done something like this earlier. If a function is even, then you have beautiful y-axis symmetry. And if you have a point over here that is x comma y, then you have one over here that is negative x comma y. And the way we test is we take our function and we replace the y with a y that doesn't change. We replace the x with its opposite. If we have an odd power on a negative, that ends up keeping the negative. 5 negatives would make a negative. So fifth power on a negative x is negative x to the fifth. The third power on a negative x is negative x cubed. We can change the signs over here on the x, but it would have an effect on the sign over here on the y. So there's no match. This graph does not have y-axis symmetry. It is not even. Odd. If a graph is odd, then you have beautiful origin symmetry. So if we have a point over here that is x comma y, we have one down here that's the opposites. So the test for odd symmetry is you replace the y with its opposite and the x's with their opposite. The odd powers on those negatives keep those negatives. And we don't have a match yet, but if we go through and change all the signs, which is legal, we're multiplying or dividing, whichever one you want to say, everything by -1, we have a match. This graph has origin symmetry, which makes it an odd function. Given the function f of x is equal to x cubed minus 3, we want to find the inverse. This -1 by the f means inverse. We want to graph them, and then we want to use the interval notation to find the domain and range. So let's find the inverse first. The thing about inverses is how the domain and the range switch roles. The x's and the y's switch. So we will physically switch the x's and the y's, and we'll solve for the new y. And we'll take that 3 and add it over here to the x. And I'll get rid of the cube by doing the cube root. And there is your inverse right there. We want to graph these. I'm just going to plot points. So here's my f function. I'm going to plug some numbers in up here to this x cubed plus minus 3. I'm just going to do 0, 1, and 2. If I need to do more, I'll do more. 0 cubed, 0 minus 3. 1 cubed, 1 minus 3. 2 cubed, 8 minus 3. Now the thing about inverses, the roles switch. So the -3 makes 0, the -2 makes 1, the 5 makes 2. And I'm just going to look at my graphs, see if I can find those points. So 0 with the -3, 0, -3 is here. Nope. 0, -3 is here. 1, -2 is here. Nope. 1, 0, -3 is here. 1, -2 is here. 2 and 5 is there. All right, on the other one, -3 and 0, -1 and 1. I'm liking this one, 5 and 2. Bam, C. Figure out the domain and the range. The domain of f. F is this graph right here on that drawing. Right there. That is your f. The domain, as you look across the x-axis, what are the points that are being used? Now this graph is going down in a hurry and up in a hurry, but it is still working its way sideways. So the domain is everything. The range of f. The range of f, you want to look at the y-axis. And this graph is going down in a hurry and up in a hurry. Your your range is also